Good morning. First, I welcome all of you here in SS College family. Myself, Subrata, Assistant Professor, Department of Mathematics, SS College, Hailakandi. Today, we are going to discuss calculus. In your textbook, chapter number 13, Limits and Derivatives. In this lecture, we discuss what is limit. Before going to the limit, I want to ask one question. What is mathematics? Now you think about. You give an answer, sir. I already got 100 in mathematics, general mathematics and advanced mathematics. And now you can ask me question, what is mathematics? Yes, I want to know what is mathematics. Mathematics depend on three words. First word is what. If I asked one question to you, then first you think what is given in your question. Next word is how, and how can we solve the question. If you know these two things, what and how, then easily we can solve any problem. But there is another word remaining, third word, why. If you know why it happens, then mathematics is easier than any subject. So we should remember mathematics depend upon on three words, what, how and why. Now we recall the function. Before going to the function, let capital A and capital B are two non-empty set. Then their Cartesian product is given by A cross B. Any subset R from of A cross B is called relation from A to B. A relation. Now question is, when a relation is said to be function, let A and B are two non-empty set. Then a relation F is said to be function if for each x belongs to capital A, there exists a unique element y belongs to capital B, such that order pair x, y belongs to F. And we write y equal to f of x. Then we said f colon A tends to B is a function. Already we know what is relation function, just we recall the relation function. In this calculus, we discuss always real valued function, that is A and B are subset of real numbers. Now we discuss basic thing of division. Already we know that 0 divided by any number is 0. But why? This is the question. Now I want to ask second question, anything divided by 0, what is your answer? On number 3, 0 by 0, what is your answer? First one, 0 divided by any number. Suppose if we take 6 divided by 2, then our answer is 3. Why it is 3? Because already we know that 2 into 3 equal to 6. So 2 into 3 is 6. So our answer is 3. When 6 is divided by 2, our answer is 3. Similarly here also, when a into 0 our answer is 0. So 0 divided by any number is 0. Now what about any number divided by 0? Can we define any symbol for which multiplied by 0 answer is any number? No. We cannot define any symbol which multiplication to 0 is answer any number. So this is undefined. Undefined. In symbolically we write infinity. Now what about 0 by 0? Whether it is infinity or not, that is undefined or not. Here 0 by 0, if we write 0, then 0 into 0 is also 0. If we write 1, then 0 into 1 is also 0. If we write 2, 3, this way. So here we see that we cannot determine what is our exact answer. So this is not undefined. This is indeterminate. This is indeterminate. Now we discuss the limit. Before going to the limit, we should know what is x tends to 2. When x tends to 2, x is near about 2 but not equal to 2. If we take number lines 0, 1, 2. What about x? X is near about 2 but not equal to 2. That means if we take left hand side of 2, that is less than 2, then maybe number x is 1.999, 1.9998, 1.9997, so on. If we take right hand side of 2, that is when x is greater than 2, then it is here x is 2.0001, 2.001, 2.01, so on. Now we want to find when x tends to 2, x square tends to y. For this, we prepare a table. And in first column we take x and in second column we take x square. Now x is tends to 2. So x is near about 2 but not equal to 2. When x is less than 2, that is left hand side of 2, we take some point. Suppose we take 1.999, 1.998, 1.997. Then what about our x square? X square is 3.9960001 and 3.9920004, 3.99880009. Now you see the value of x square. This is tends to y tends to 4. So when we take x less than 2, tends to less than 2, then our x square tends to 4. Now we take right hand side of 2. That is when x is greater than 2. 2.0001, 2.0001, 2.001. Then what about our x square? X square is 4.00001, 4.00400. 4.0040001. That is, here we see x square also tends to 4. So, when x tends to 2, then our x square tends to 4. So, our answer is from table we find when x tends to 2, then x square tends to 4. Then we can write limit x tends to 2, x square equal to 4, or LT x tends to 2, x square equal to 4. This is the concept of limit. Now, we move to the actual definition of limit. What is limit? A function f of x is said to be tends to a limit L when x tends to a. If for given epsilon greater than 0, there exists delta greater than 0 such that mod of f of x minus a less than, mod of f of x minus L less than epsilon when mod of x minus a less than delta. Then we write limit x tends to a f of x equal to L, or LT x tends to a f of x equal to L. Now we take an example. Find limit x tends to 0 f of x, where f of x equal to x minus 2 when x less than 0, equal to 0 when x equal to 0, equal to x plus 2 when x greater than 0. Already we know that when x tends to 0 means x is near about 0 but not equal to 0. So our x takes less than 0 and greater than 0 value, near about 0 but not equal to 0. So for this we prepare a table. Column 1 x and column 2 f of x. Now first we take x tends to less than 0. That is, we take minus 0.001, minus 0.01, minus 0.1. So when x is less than 0, our fx is x minus 2. X less than 0, fx is x minus 2. So we put these values here, x. So when x is 0.01, our fx is minus 2.01, and when x is 0.1, then our f of x is minus 2.1. Now, when x is tends to less than 0, then our fx tends to 1. You see from here, our fx tends to minus 2. Now we take right hand side of 0, that is when x is greater than 0. Near about 0, but not equal to 0, but greater than 0. We take some points, so we will take 0.001, 0.01, 0.1. So you see our function, when x is greater than 0, our fx is x plus 2. So when x is 0.001, our f of x is 2.001. When x is 0.01, our fx is 2.01. And when x is 0.1, then f of x is 2.1. Now when x is greater than 0, then what about our f of x? Our f of x tends to 2. But in last problem, we find when x tends to 2, then x square tends to 4. When x tends to greater than 2, x square tends to 4. Also, when x tends to less than 2, then also x square tends to 4. So our limiting value of x square is 4. But here, when x tends to less than 0, then our f of x tends to minus 2. And when it is greater than 0, then our fx is 2. So this shows that there are two limits. One is left hand limit, that means when limit x tends to less than 2, we write x tends to 2 minus. That means symbolically we write 2 minus, but actual meaning is when x is less than 2. Then our answer is minus 2. And in right hand side we find right hand limit. That is when limit x tends to greater than 2. That is limit x tends to 2 plus f of x. Then our answer is 2. So from here we find the concept of left hand limit and right hand limit. Now what? Now we move to the left hand limit and right hand limit. What is left hand limit? LHL, limit x tends to less than a. That is left hand side of a, f of x. And what about right hand limit? Limit x greater than a. That is x tends to a plus f of x. If left hand limit equal to right hand limit, then our limit x tends to a f of exists. If left hand limit not equal to right hand limit, then limit x tends to a f of x does not exist. Does not exist. This is the concept of left hand limit and right hand. For better understand left hand limit or right hand limit, we move to the next problem. In next problem, to find limit x tends to 0 f of x. And question number second, limit x tends to 1 f of x, where f of x equal to mod x. Already we know that what is mod x. Mod x equal to x when x greater than 0. Equal to 0 when x equal to 0. Equal to minus x when x less than 0. That is our fx equal to x when x is greater than 0. Equal to 0 when x equal to 0. Equal to minus x when x less than 0. Now, our first problem. Whether in this problem left hand limit or right hand limit required or not, that is the big question. Here you see x tends to 0. That is x less than 0 and greater than 0 but not equal to 0. When x is greater than 0, our fx is x. And when x is less than 0, our fx is minus x. So here fx given two different values. When x is greater than 0 and less than 0. So we need left hand limit and right hand limit. So in first problem, we need left hand limit and right hand limit. We find left hand limit equal to limit x tends to less than 0 f of x. Now, you see our function. When x is less than 0, our fx is minus x. So we put here minus x. Already we know that when x tends to 0, minus x is also tends to 0. So our limiting value is 0. Next we find right hand limit. Limit x greater than 0 f of x. Now again look at the function. When x is greater than 0, then f of x is always given x. So we put limit x tends to 0 x. Now our answer is when x tends to 0, limit of x tends to also 0. So therefore left hand limit equal to right hand limit. Therefore limit x tends to 0 f of x exists and limit x tends to 0 f of x equal to 0. Now we move to the second problem. In second problem, we want to find limit x tends to 1 f of x. Now we take number lines 0, 1. Here x tends to 1. When x is tends to less than 1, that is this point from less than 1, that is left hand side of 1, then our x is greater than 0. This one. When x is greater than 0, our fx is x. So here we get fx is x. When x is greater than 1, that is this portion, that is right hand side of 1, then also our x is greater than 0. So here also we get x. In both cases, left hand side and right hand side of 1, fx is given a single value of x. Single value of x. So here we don't need left hand limit and right hand limit. We directly find the limit. Second one, limit x tends to 1 f of x. Limit x tends to 1. Since f of x is x, so we write 1. So, from these two problems, we understand when left hand limit and right hand limit required or when don't require left hand limit and right hand limit. Thank you for watching first lecture on limit. In second lecture, we discuss different standard of limit and different problems.